Hey guys, this is Mrs. Harbin, and this is Algebra 1. Today we are looking at Unit 7, which is all about solving systems, and we've learned how to do it by graphing. Today we're looking at how to use substitution. Now, before we get into our steps for today, let's do a couple warm-ups that involve some simple substitutions. We've been doing substitutions all year by substituting different values in for x or for y. So let's try one. Let's solve 2x plus 3y equals negative 10. We're going to solve it for y by substituting the given value for x. So we're told here that x equals 4, which means everywhere we see an x, we are going to substitute in a 4. And just like I've been saying all year, we're going to use parentheses when we substitute. So we get 2 times 4 plus 3y equals negative 10. Go ahead and try to simplify that on your own. Pause the video and then come back and check your work. All right, hopefully by now you've simplified that on your own and you got 8 plus 3y equals negative 10. You then wanted to get the 3y by itself, isolate that 3y, so we've got to subtract 8 from both sides, which gives us 3y equals negative 18. And then finally, y is being multiplied by 3, and the way that we isolate the y is to divide by 3. And when we do that, we get y equals negative 6. Let's try another one. This time, let's solve 2x plus 3y equals negative 10. We're solving again for y by substituting this value of x. X equals negative 2. So everywhere we see an x, we are going to use parentheses and substitute a negative 2. So we've got 2 times negative 2 plus 3y equals negative 10. I'm not going to simplify this one on the screen, but I will let you pause, work this one on your own, and then check your work. And hopefully when you did all of the correct steps to simplify, isolate, and isolate, you got that y equals negative 2. All right, this time let's solve 2x plus 3y equals negative 10 for y again by substituting the given value of x. And then this time, instead of substituting a number, everywhere we see an x, we're going to plug in a y. So we've got 2, and instead of x, we're going to substitute in a y. 2y plus 3y equals negative 10. Now this one I am going to simplify with you here. We know that to get rid of these parentheses, we can just write 2y plus 3y, since that just means multiplication. And then as we're simplifying, I see we've got like terms on the left. 2y and 3y are like terms, so we can combine those into 5y equals negative 10. At this point, the y term is by itself. Let's isolate the y. It's being multiplied by 5. The way that I undo multiplication is division. So I'm going to divide both sides by 5. And when I do that, I get y equals negative 10 over 5, which simplifies to negative 2. So far this year, we've only been substituting numbers, but we can substitute anything. Here, we substituted another variable. In this next one, let's go ahead and substitute not just a variable, but a whole term here. So now for x, we're going to substitute in 2y. So that will give us this equation. Instead of 2x, we'll have 2, substitute 2y, plus 3y equals negative 10. We know that we're going to have to get rid of these parentheses first by multiplication. So 2 times 2y is 4y plus 3y. Equals negative 10. And from there, I'll let you simplify that on your own. Come back when you're finished to check your work. All right, hopefully you saw that these are like terms and you could simplify those. So you got 7y equals negative 10. You then realized you needed to isolate the y, which was being multiplied by 7. And the way that you do that is to divide by 7. And we got to do that for both sides. So what we end up with is y equals negative 10 over 7. This is a fraction that cannot be simplified. There are no common factors of 10 and 7. We're not going to write it as a mixed number. We're not going to write it as a decimal. We're just going to leave it just like that, negative 10 over 7. All right, let's go ahead and solve this one again. But this time, instead of having just one term, we're going to substitute this whole expression, or 2 terms. So everywhere we see an x, we're going to substitute y plus 5. So that would look like this. Instead of 2x, it would be 2, and then in parentheses, we write what we're substituting, y plus 5 and then the rest of the original equation, plus 3y equals negative 10. Remember, our original equation was 2x plus 3y equals negative 10. And all we did was substitute for that x. Instead of x, we substituted the expression y plus 5. Now let's go ahead and simplify. I do know I need to multiply, but I've got two terms in here. So I need to multiply 2 times everything, which we call distributing. So we're going to distribute to get rid of this parentheses. So we've got 2y plus 10 plus 3y equals negative 10. I know that I need to continue to simplify. I've got some like terms here. So 2y plus 3y equals 5y plus 10 equals negative 10. After I simplify, I need to isolate the term that I'm trying to solve for here. I'm trying to solve for y and the 5y. So I need to isolate that. It's got a plus 10 with it. I'm going to get rid of that plus 10 with a minus 10. Whatever I do to one side, I have to do to the other. That gives me 5y equals negative 20. And then from here, hopefully you can simplify on your own. Y is being multiplied by 5. How do I undo that? I divide by 5. So when we divide both sides by 5, we do get y equals negative 20 over 5, which simplifies to y equals negative 4. All right, so we looked at solving some equations by substituting just numbers. We substituted in another variable. We substituted in the term, 2y, and we substituted in this whole expression, y plus 5. Remember that anytime we substitute, no matter what we substitute, we do need to use parentheses when we substitute. All right, so now that we've got that under our belt and reviewed substitution that way, let's talk about solving a system. So far, we've looked at solving a system by graphing. And this works well if the coordinates of the solution are small integers, like 3, 4, or even 7, negative 2. It doesn't work well when you're dealing with large numbers or with fractions. Because large numbers, your graph would have to be huge, and fractions, you can't always tell what they are on the graph precisely because they don't intersect at a nice, neat integer. So if we're dealing with larger numbers or fractions, we need to use another method. And so that's what we're going to look at today. Our objective for today is that you, the student, will solve simple systems of linear equations by the substitution method. All right, let's talk about this vocabulary. Remember that a system of equations just means you have more than one equation. In all of our cases, we'll be solving 2. Linear equations means that you've got a y and you've got an x. And you might have some other numbers in there, but you've got a y to the first power and you've got an x to the first power. Plus, whatever numbers. That's a linear equation. So we're going to solve 2 or more equations that have a y and an x, and we're going to do that with a substitution method. All right, the substitution method is used to find first a single variable equation by replacing one of the variables with an equivalent expression. Like we just did in our warm-up, we replaced x with y plus 2. When we replace one of the variables with an equivalent expression, we now have an equation with just one variable. This will make a lot more sense as we start working through problems together. Once that equation is solved, we can then substitute again to find the value of the other variable. So let's look at an example together. Here's our system of equations. You can see it's a system because we've got 2. They're linear equations because they both have x and y, x and y. All right, so the first thing we want to do is to solve for a variable. We want one of these equations to be x equals or y equals. And as I look, I notice that my second equation is already y equals. I have an equivalent expression for y. Y equals negative 3x plus 7. Well, just like I was doing in the warm-up, what I can do now is, in this first equation, everywhere I see a y, I can plug in this equivalent expression. So let's see what that looks like. So we have x plus, and instead of y, we've written the equivalent expression for y. Negative 3x plus 7 equals 5. And what that does is now I have only x's in my equation. I got rid of that y. Now I can actually solve and find a numerical value for x. So when we simplify that, we're going to combine our like terms. X plus negative 3x gives me negative 2x. plus 7 equals 5. We need to isolate our negative 2x since we're going to solve for that x here. It's got 7 added to it, so let's subtract 7. And whatever we do to one side, we have to do to the other. That gives us negative 2x equals negative 2. And then finally, we want to get the x by itself, and it's being multiplied by negative 2. And the way we undo that is to divide by negative 2. Whatever we do to one side, we have to do to the other. And that allows us to find out that x is equal to 1. Well, now I know a numerical value for x. So now I can go back to my second equation, and everywhere I saw an x, I can plug in a 1 or substitute in a 1. So we know that y equals negative 3x plus 7. Let's substitute that 1 in. Y equals negative 3 times 1 plus 7. And simplify. Negative 3 plus 7 is 4. Just like when we were graphing, because these are intersections, that's what a solution is. It's the one x and y value that will work for both equations. So just like when we were graphing, we're going to write our final answer as an ordered pair. So our solution is 1, 4. Our x was 1 and our y is 4. And that is the only x and y value that will work for both of these equations. All right, let's try a second example. I'm actually going to go through this one maybe a little bit quicker so we can get to our steps here. We've got x plus y equals negative 4 and x minus y equals 10. Now, in these equations, I don't have one yet that's solved for x or y, so I need to choose one and solve for either x or y. And I'm going to do this first one, solving for x. So I subtracted y from both sides. I get x equals negative y minus 4. Now that I know what x is, I can go to my second equation and substitute that expression in. So everywhere I see an x, I'm going to substitute in negative y minus 4. And then the rest of our equation, minus y equals 10. From here, we simplify by combining like terms. Negative y minus y is negative 2y. Minus 4 equals negative 10. Remember that this is not multiplication because we've got a plus or minus sign in between here. So we're not multiplying anything after by this parentheses here. We need to get the 2y by itself, so we add 4 to both sides, and we get negative 2y equals 14. We then need to get the y by itself, so we divide by negative 2, and again we do that to both sides, so we get y equals negative 7. Now, if y equals negative 7, we can substitute, everywhere we see a y, we can substitute negative 7, and then solve for x. So here is our original expression or equation that we solved for. X equals negative y minus 4. Now we take that negative 7 and plug it in. Now we're going to be careful and use parentheses when we substitute here. So x equals negative, and then our parentheses, negative 7 minus 4. That negative times a negative becomes a positive, so we get 7 minus 4, or just x equals 3. We'll write our answer then as an ordered pair, 3, negative 7. All right, let's talk about the steps of solving a system by substitution. And I'll give you a handout with these when you get to class as well, but please make sure you write them down first. You're going to solve either equation for either variable, either the x or the y, like we did in the second one, x equals negative x minus 4. Choose the easiest one to solve for. So choose a variable that doesn't have a coefficient. Then substitute the solution into the other equation, or substitute that expression. Remember, we got x equals, or y equals negative x minus 4, or x equals negative y minus 4. We substituted that whole expression into the other equation to obtain an equation with one variable only. So your whole equation should have just x's or just y's once you substitute. And then we solved, and we got a numerical value. Once you find a numerical value of that variable, you plug it in to the other equation to solve for the other variable. Fourth, you write the solution as an ordered pair. And last but not least, check your solution by substituting it into each equation. Plug in your x and your y into both equations to make sure it really does work and you did not make a computational error. We'll do a lot of practice of these in class, and make sure you have those 5 steps written down, as long as your examples and any vocabulary that you heard. See you guys in class.